Okay, I'm going to introduce you to the idea of inverses. Some functions have inverses, some do not. And when I mean inverses, I mean when you invert them, will they still be a function or not a function? So here's one way you can tell, or a couple ways you can tell. When you have your function, swap the original equation, the x and y's, then solve for y, and whatever the new equation is, that will be the new inverse function. For example, if we have the original is y is equal to x squared, we swap the x's and the y's, then solve for y. Well, I need to take the square root of both sides. So the square root of x is equal to y. So the square root of x is the inverse of x squared. So that's algebraically. Graphically, this is what you need to know. X's and y's, just like up here when we swap the x and y, well, graphically, if you have coordinate points, you can swap the x's and y's to determine if they fit the criteria of an inverse. So here we have 1, 3 right here, and then 3, 1. And how you can tell is if there is this invisible diagonal kind of dashed line at a 45-degree angle, notice that if you were to fold, let's say that was on a piece of paper, and you were to fold it up over that diagonal, this point would sit right on top of that point. And that's how you know it is a function or not. So to recap, when you have functions to find the inverse, swap the x and y, solve for y like I did here, and then if you want to write into inverse notation, you would just tack on this raised -1. That means that this function is the inverse of that function. And then I'm going to talk to you about the limits of domains for functions. But I'm going to stop that right now. That's just the general explanation of inverses.